Good afternoon, this is Richard Dennys. Today I'll be talking to Gary Wilson. He is the Chief Architect of Anomify and also the maintainer, curator, general wizard behind an anomaly framework called Skyline. Hi, Gary.
Hi, Richard.
How are you doing? Interestingly, why was it called Skyline?
Well, if you're looking at a cityscape and you want to detect like the most anomalous things, you're looking for the skyscrapers, etc. So It's a skyline.
It's a skyline, so it's obviously different parts of a cityscape. Interesting. And introduce yourself and what you kind of do at Anomify, but also the background to how you have involved and what the interaction is between Skyline and Anomify now these days.
That's quite a large topic. I'm Gary. I sort of do ops and DevOps and monitoring anomaly detection at Anomify. We kind of, over the years, we've kind of developed the anomaly detection side to pretty much help know what's going on in sort of massively complex and distributed systems that have thousands of metrics, just watching everything so that it's not up to somebody to look at dashboards and things like that.
Yeah.
And
it was born
to find things that we don't know about.
It was born out of an advertising technology business, right? So that's where it came from.
Yeah. So there was an ad business, and we were scaling massively. We were running like in 13 data centers around the world, and at the peak we had like 438 servers deployed. This is back in the day in 2016-ish. And the observability and monitoring pipeline we had was good, but it was limited in terms of the amount of data that we were ingesting. And we were a really small ops team of 2 people. So watching all that stuff was kind of impossible. And we had hundreds of publishers running hundreds of tags, and we had real-time advertising, bidding through exchanges, etc. So watching all this stuff was kind of impossible for 2 people. So at the time, there was a very basic, Etsy had published a very basic sort of anomaly detection application that they ran on their side, and they tried to do a lot with it, but eventually they sort of abandoned it because they found that the one sort of size doesn't fit all. And they were doing 250,000 data points per second, just crazy stuff on a massive machine with massive amounts of memory. We never had the same luxury of having anything like that. So we kind of focused on further developing that application, but on commodity hardware. And over the years, trying to make it better because it was very noisy. And that's just been a journey. That's just been a journey of 10 years now, almost.
Wow. And so that's so this is the gestation of Skyline, and you are still heavily involved in maintaining that, right?
Yeah. So Skyline's very complicated. It's a very complicated, very complex application with a lot of different moving parts. And from Anomify's point of view, we do all that as a managed service, and we take away all the complexity from the person that's using it. They don't have to worry about what it's doing, how it's doing it, how it's configured, where the data sits, all the rest of it, clustering it, making it redundant and resilient, and all of that kind of stuff, which is pretty hard to do when you're working with very fast moving data that's coming in constantly being streamed.
Yeah, and well, talk a bit more about that, and how have you developed the algorithms over time, and introducing some of the AI ML techniques on a high level? How has that been?
on a high level, trial and error, basically.
Yeah.
So it's anomaly detection, funnily enough, is one of the hardest domains in data analysis. And it definitely is in machine learning and deep learning. And it's kind of the one area that AI, like general AI models and deep learning models, haven't really had a massive impact on. There's been a lot of things done. There's been a lot of new methods and models and deep learning algorithms, etc., that have come out. But in terms of the reality of how effective they are, really, you can do a lot of this. You can get very similar results with extremely simple algorithms. And I think over the years, and definitely now, what people in the field are starting to realize, which has always been the case, but when people start looking at anomaly detection and working with it, they kind of think, okay, I'll implement this and analyze the data with this algorithm, et cetera, et cetera. And the truth is, there's no one method that will give you good results. It might give you good results in one arena with one kind of data, but it won't give you good results with all kinds of data. So anomaly detection has been pretty difficult for anybody that's looking to do it. You can implement something yourself and get it working, but then once you start using it, you realize that it's not perfect. And now this noise, I've got a saying that you can't teach stats and you can't teach models. Once you've created a model, once you've got a statistical algorithm and it does what it does, you give it data, it gives you an answer, and that answer is always going to be the same. And even if the answer is wrong, you can't change it. You can't make it go, oh, if it's like this, do this. So you could do that, but that would be masses and masses of rules, et cetera, et cetera. And that's the thing. Trying to get rules that match everything is extremely difficult. So from our point of view, like our journey has been finding out all these little ins and outs of different things and different data sets and different types of data. And over time, sort of evaluating, right, why doesn't this work here? Why doesn't that work there? And there's a number of things you can do to make it somewhat better. But the reality is that it doesn't matter what algorithms or methods you use, it might always sometimes get it wrong. So
but I guess
I spent a lot of time focusing.
The challenge there would be, you're saying that it's always going to be wrong. There will always be false positives. You can never erase that. But the challenge is the extra marginal gain every time, the tiny amount of difference that can make massive difference to a large data set.
Yeah, well, so from that point of view, I started focusing on trying to develop a method that you could actually train the system on, like something. This is not an anomaly. It's normal in this data set. This whole data set is normal. And I spent a couple of years sort of proof of concepting that and putting it into testing everything. And out the back, I got a method that actually works, and it works incredibly well. So getting anomaly detection better is not just about getting one algorithm to do something better. It's about putting a pipeline of lots of different methods that deal with different data in different ways, etc., and identify different states in the data and trends and analyzes it appropriately to those things. And actually doing training and being able to train is massively effective in like reducing false positives, like hugely. And the method gets it right. That's one thing that we've always tried to do, is do things that are right. And by that, I mean they're accurate, because you don't want to introduce false negatives. You don't want your system sort of an anomaly coming through, like a significant anomaly, a real anomaly coming through, and all your methods go, oh, really, this isn't an anomaly. So all of our testing, etc., is focused on reducing false positives, but also very much so not incurring false negatives. So, with that method in place.
And Gary, you see in the marketplace, there's a number of different, I'd say, frameworks or platforms or providers of anomaly detection out there. And are you saying that the key differences are the ability to detect and train on those false and true positives, or is it more around the algorithm types or the ability to learn from a cold start? What marks a good one and a bad one?
Well, a lot of things that are out there right now, I kind of put them together in a one-trick pony. And the cloud providers have got on board. Amazon's got, anomaly detection, ML detect, functions, etc. So does Amazon. They've got CloudWatch anomaly detection, which is built pretty much on random robust forest. And there are other services out there. Oracle's got one. Azure's got one. But most of them are one-trick ponies. Okay. So it's basically you're going to throw data at something and it's going to come back. And the results of that are generally pretty poor. They just create a lot of noise. And it's quite interesting that the cloud providers, I think they're focusing on the spend aspect. If you look at their models that they use, Google's using auto-arama, and auto-arama takes how many seconds to train? An auto-arama model on 7 days of data. And Amazon's pretty much the same. Oracle's training on the same set of data is taking around 17 minutes.
And how does that compare to Skyline?
We analyze data in milliseconds.
Right.
And if we do additional analysis on it, all the analysis is probably done depending on how much training there is on a metric. Most of the analysis is done maximum 7 seconds.
Okay.
But the point there is that the cloud providers I think they're implementing these kind of things because these are really heavy compute intensive algorithms, and that's what you're paying for. You're paying for all of that time that it's taking to compute all of these models, and you're being charged for that. So taking the longest running models and implementing them, I just think it's more about making money than being useful to anybody user's point of view. And the important thing there is we eat the dog food. This is what we do. We don't. It's really easy to come up with numbers and performance metrics, et cetera. But at the end of the day, if you're doing it yourself and you're not testing it, you're just being disingenuous to yourself that actually, hey, we've improved this. It's better now. It's more accurate. It's this. You can't hide from those facts when you're doing it yourself, and you're trying to improve it. There's no point in going, oh well, actually maybe it's better and maybe we should just use numbers. So from that point of view, testing it yourself and doing all of that and trying to keep it performant and fit for purpose. So from our point of view, fit for purpose is that we can ingest and analyze data like within the same minute.
Within the same minute, yeah, that's very cool. And that's obviously from a Skyline point of view, but then the Anomify managed service on top, which is obviously where you spend quite a lot of time as well, and also where the team spends their time in making things a bit more digestible and a bit more pertinent, and you can understand the business insights too. Skyline seems to be fairly complex, and you need to have a level of deep knowledge to be able to install it yourself on your own instances. So do you want to just talk a bit about why Anomify?
Yeah, well, if you're not doing anomaly detection, in your monitoring and your observability pipeline, then you're doing your organization and your people and your developers and your operations people somewhat of a disservice, because there's so much stuff that we deal with nowadays that we don't know what everything is. And nobody can really be expected to know what everything is. So there's definitely a need for anomaly detection. It's quite a hard thing to sell to the market, because it's not something that a lot of things you just sign up to them, turn it on, and it's, oh, there's results. Anomaly detection is kind of a journey. And it's basically something that's teaching you more than it's telling you things. You're constantly learning. It'll constantly be flagging up things over time, like, what's this? And why did this thing change? And what happened here? And the reality is that there's a lot of, personally, I believe there's a lot of misconceptions in terms of, oh, what anomaly detection is. Oh, I'll turn it on and it'll tell me something's wrong and I'm not going to lose money. That's kind of a myth. It does do that, but that's not its main purpose. Its main purpose is to inform people and help give us insights into all of these complex applications that we run. And from that point of view, the amount of insight and the amount of learning you can gain by using anomaly detection is just, it's very hard to even quantify until you've experienced it. Before you do anomaly detection, you run stuff. And after you've been doing anomaly detection for a couple of months, you're really aware of how a lot of things that you run work and what they do and what impacts you and your business and your users and your application use has on the different things. It basically tells you a story of things that are happening in your organization and your services, et cetera, et cetera. And that really is priceless from a point of view. Like, you could sit down and look at graphs and look at all of your metrics for weeks, months on end, and still not find those same signals that you'd be finding running anomaly detection. And from a performance point of view, the whole monitoring space at the moment, a lot of people are using sort of commoditized alerting rules, et cetera, that look at specific metrics and they alert if something goes wrong, which is all good and well. But underneath those ones that are looking at alerting rules, there's hundreds and thousands of metrics that are related to the performance of whatever thing whether it's a Linux server or whether it's Redis or whether it's a database or whether it's this or whether it's that. And all of those alerting rules, they're really not taking into account any of these things. So there's vast opportunities in an organization and a development team where our implementation of features and our implementation of things is all good and well and it all seems to work. But if we're not actually monitoring the underlying stack that's there, we can ship a lot of things into our environments that might work, but really aren't efficient.
Yeah. And
if nobody's seeing those things, those inefficiencies and those performance hits just incrementally start to stack up. Months down the line, you're going, why is this thing stupidly slow? What's this thing happening? Somebody goes, looks at some obscure metrics that nobody's ever looked at before and goes, let's go back, if they're lucky enough to have a couple of months, and they go, oh, something happened here. What happened there? There was deployment, this. And all of a sudden, the application that was working really well, over the course of a month or a couple of months, there's been a few feature releases and some of them weren't done as well as they could have been done, but nobody knew. So it really helps you as a team to keep an eye on and a check on yourselves. Anomaly detection, one of those myths is, there's going to be these outside actors or something, and it's going to detect this, and it's going to detect intrusions and all the rest of it. But the reality is that probably 90% or more of issues are created by ourselves. A lot of the time it's friendly fire. So,
super interesting. But at least you can identify it. I mean, I often talk about, when I'm talking about big data, I talk about the what, the so what, and then the now what. So it's basically taking the data that you have, which I suppose would be those true positives or false positives, putting them into a situation where you can contextualize it. So it's like, well, so what? Are these important? Are they not important? But then the really key thing for any organization is the now what. What's the insight that we need to take and move forward on this? And I'm guessing the way that Anomify can set things up will allow all three areas to be covered.
Yeah, well, the output, it gives you a timeline, a stream of significant and anomalous, unusual, unexpected behaviors. So, that allows you to tie those events up with things. Oh, there was this release done. We released version X, or we upgraded this thing, and at this time, all of these things happened. So, it's although we do a lot of correlations and tie things up and actually analyze all the time series and correlate what things happen when and relate events, and we relate what metrics are related to what metrics, etc. And all of that information is useful. But at the end of the day, there's only so much that algorithms and AI can do. And at the end of the day, the people that build these systems and maintain systems and software, they're the people that know. So,
but at least you get a distilled version of that. So it's not as if it's just white noise. At least it's a narrow
it's
point.
Definitely not. And you can just scroll through the timeline and you can go, or you can query at this timeline what happened around here. So from that point of view, it's giving people access to information that otherwise they wouldn't have. A lot of the things, if you were detecting on a lot of your application metrics, a lot of the things that are being monitored are just not in any dashboard anywhere. Nobody bothers to ever look at them. And that's another thing. There's some metrics that might not seem important, but under certain circumstances, all of a sudden they become important. And it's finding those unknown unknowns and flagging them up that's really useful to people understanding what they're doing and the applications and services they run and all the different sort of factors that those environments are subjected to.
Okay, so you say that you spend quite a lot of your time developing the algorithms and trying to identify better ways to catch these anomalies and obviously pushing them through to the false and true positives. How much further can we go with current sort of techniques and understanding? Where might that go in the future? For example, I was reading about quantum computing the other day with the qubits and everything else, that takes things to a completely different level. Is that going to lead to a new frontier in this area, or do you think we are approaching the area of peak detection?
Well, it's hard to say. My gut feel is that there's a ceiling that you hit, and at the moment I'm contemplating have we hit that ceiling? We're getting an accuracy rate of 94% now.
Wow! And
there are a few things during the last year that, during testing, I've got 2 or 3 things that I can implement that we can possibly take that and push it 1% or 2% up. But pushing the accuracy in time series anomaly detection even 1% is just a huge, massive achievement. So have we hit a plateau or pinnacle? In terms of general anomaly detection, I'd say possibly. There's always room for improvement, room for performance increase. But from point of view of specialized detection, so specialization of different methods for specific types of data sets and stuff, there's still room to grow there, I believe. as far as what's next on the horizon, quantum computing, yes, will probably take leaps and bounds. In the current sort of AI space and deep learning space, there's been massive leaps and bounds with large learning models, which are transformer-based. And there is some research and, some application of using GPT, general purpose transformers, on time series data, and they have released time GPT. But from that point of view, once again, a bit like ChatGPT, it's sometimes going to get it wrong.
Yeah, and hallucinate too.
And
yeah,
it's going to hallucinate. And for predictions, it's quite good. But then again, the value of predictions is something going to be within this range of normality. And whether you need a quantum machine or thousands of GPUs to actually determine that, what's the expected range. So in some ways, like deep learning and those kind of models are really, really massive overkill for not necessarily achieving better results than older models. And Eamon Keogh, who's sort of one of the godfathers of modern time series analysis, as far as I'm concerned, he's been going on for a number of years now. That's all the benchmarks and all the results and all the progress that's apparently being made in this domain is just a fallacy. It's based on bad data sets. It's based on bad benchmarking sets, and he's been quite vocal about this for a few years. And he's a professor at Riverside University in California, and pretty much one of the leaders in the space, and has been for a number of years. And I fully agree with him. I definitely fully agree with him in terms of, after testing and working with loads of different algorithms over the years, he's definitely pretty much 100% correct. A lot of new things that come out are just published because a student needs to be published to get their PhD. Or there's a whole thing in science to how many publications can you get, and a lot of it is just really it's not really moving the state of the art along. It's just going, I'm going to take something, change it a little bit, and get different results and publish them. So there's very little there's very little, what's the word I'm looking for? Useful advancement in a very high volume of new sort of methods, etc., that come out. There's very, very few that are actually useful in terms of real world application.
Okay. And
that always comes down to it, like the compute complexity and the time complexity of how long these things take. Okay. So
it sounds as though, there's been a lot of great leaps and strides in terms of the accuracy of these systems, and particularly the ones that Skyline's using and now Anomify enabling. If for somebody who's fairly new to this, or who understands the monitoring as per se, what would be the first step? So we've talked about the future, but what would be the first step today if somebody just thinks, right, I think I'm ready to leap into this now. What should I do? How do I do it? What's the quickest way to get going, and how long might it take?
Well, to be honest, I think anybody that wants to do anomaly detection has to start out with realistic expectations. You're not going to take your millions and millions of time series that you're collecting and go, oh, just throw them and anomaly detect on them, because that's really not what you want to do. Because we've got a problem in the world now that we've just got metric overload and data overload. We're collecting so many metrics that probably 90% or 99% of the metrics that are being stored right now in the world are never ever looked at before they move through the retention period and get pruned out of existence. And that's because we've kind of feasted ourselves on being able to just send as much time series data as we want to. So I think the first and most important thing is if you want to get involved in anomaly detection and gain the benefits that you can gain from that, is be realistic and sit down and look at your metric population and decide on one or two things that you want to start with, and sign up and configure your Prometheus or your Graphite or Telegraph or whatever collector you're using to just send those metrics and run them in and start to learn what it's about and what it's going to give you. And then as you go along, identify things that you're not covering in alert rules, that actually we should probably be monitoring this. So there's quite a lot of database things that we're not monitoring. That's important. Let's chuck like all these databases. And, it's a case of discovery as well, because you'll have a lot of metrics in your database that actually are really useless. So going through the metrics that you've got, and in terms of cardinality, you might have thousands of database services. Just pick a couple and send from them and see what happens, which ones over time, over a month or so, you'll figure out what's, just seeing them and being exposed to them, you'll figure out what's important. And if you're not seeing stuff, any changes in Stump, and then you can take that and you can go, right, let's select all these metrics from all of the database servers and send them in for anomaly detection.
So that sounds like a couple of quarters. So once you get going, maybe 3 to 6 months just to see how things lie, and then you can go into different avenues from there. Or could it be quicker than that?
It doesn't have to be that long. It can be a process of weeks. But the general point is send less rather than trying to send everything. Mm-hmm. And then, you'll get to a point where you go, okay, well, we've got most of our applications and most of our request metrics and error metrics and all of those things monitored now. We're sending all of those things through and they're being monitored. They're not just being collected. We're actually physically monitoring them constantly in real time, 24 hours a day. So it doesn't have to be months and months. It's more a case of start small and get a feel for what's happening and what's going in, and then take a view of all your metrics and look at all the things that you're not monitoring and should be monitoring, and get the key performance metrics out of those different applications and services or whatever they may be, and start to send those. And sending them is pretty easy.
Yeah,
it's pretty trivial to send the metrics.
Sounds good. I mean,
that's.
So anything? I mean, we've covered pretty much everything. I think from the gestation and the birth of it all, the Skyline, and also how Anomify can help. You're very active with the Skyline community, I guess. You are Earth Gecko in that community. You're well known, and also you can be accessed through the system here. Are there anything key that anyone needs to know about the systems, just as we close this conversation?
I think the key point you need to ask yourself is, are we doing anomaly detection on our stuff? Why not? Why wouldn't we do anomaly detection on stuff?
Yeah.
In today's world, it's a case of we collect all this data, but it's not being utilized as much as it could be. So we're incurring the cost of it, but if it's not being used and nobody's looking at it, what's the point of using it? What's the point of collecting it? What's the point of storing it? And, organizations are spending tens of thousands of dollars a month, a lot of them in collecting all the stuff, but it's not really being, you've probably got 5% of it that's being monitored via some kind of alerting rule, and the rest of it just sits there. So, I think the question is, the key question is, how can we put that data to use usefully?
Fantastic.
And that's the key takeaway.
Yeah, perfect. I mean, I think that's always the case, isn't it? It's just to work out what the nuggets of information are to help you run your business properly, and to make sure that the bad guys don't win, and also that the business is as friction-free as possible. Gary, that's been amazing. Super interesting. This is the first time we've done these. I'm sure there'll be more coming in the future on all sorts of specific and general areas. But thank you so much for your insight in this area. to reach you, I guess they can do a Google search for Skyline and EarthGecko.
Oh, they could just come to anomify.ai.
And I was just about to say the quickest and easiest way is to go via anomify.ai. Thank you so much. That's been super interesting, and I'm looking forward already to the next one. Thank you.
Pleasure. Thanks, Richard.